Hey y'all, today I'm going to break down the top 3 general chemistry topics that you absolutely must know on the MCAT. If you make sure that you really understand these 3 areas very, very well, then you're gonna likely significantly boost your ChemPhys score, and you'll quickly be able to spot exactly what the test makers really love to ask about. So let's dive in. The first topic is acid-based chemistry. Why it's important is because acid-based chemistry appears constantly on the MCAT. It is your number 1 Gen Chem topic you need to know, especially because it really connects directly to biology, biochemistry, and physiology. Your top must-know concepts are first, definitions. Arrhenius, Bronsted-Lowry, and Lewis, acids and bases. You need to know your pH and pOH calculations very well. Know these cold. pH is negative log of H plus, pOH is negative log of OH minus. And then remember, pH plus pOH always is going to be 14 at standard conditions. You also really need to understand strong versus weak acids and bases. Your strong acids and bases are going to dissociate completely in water, so think HCl or NaOH. And your weak acids and bases are only going to partially dissociate. Understand Ka and Kb values and how the equilibrium really helps you identify stronger and weaker weak acids. And then you need to know buffer systems. Buffer solutions resist pH changes, and you need to understand the Henderson-Hasselbalch equation inside and out. Typical MCAT questions relating to acids and bases, you're often going to see buffers within biological contexts, maybe blood pH maintenance or enzyme activity. You want to make sure that you really practice interpreting titration curves, and you want to make sure that you know how to spot equivalence points, half equivalence points, and buffering regions within your titration curve. So, quick recap. For acid-based chemistry, you want to make sure that you really understand the definitions, the calculations, and the buffer systems. This is going to be a huge payoff on exam day. Okay, let's pivot. Second topic is electrochemistry and redox reactions. First, why is it important? Electrochemistry, it really is everywhere within the body. You've got your neuron action potentials, metabolic energy production, and batteries as well. So the MCAT loves to test this. Your top must-know concepts are, you've got redox basics. So I always like to use the mnemonic Ulrich. Oxidation is loss of electrons, reduction is gain of electrons. So remember, Ulrich applies specifically to electrons. You also want to know your electrochemical cells. Galvanic cell versus electrolytic cell. Galvanic cells are spontaneous, so positive voltage, negative delta G. Electrolytic cells require an input of energy. That's the big difference. You want to understand cell potentials, your E cell. You want to know how to calculate your standard cell potentials using reduction potential tables. Don't flip signs randomly. Remember, you're going to reverse the potential for the oxidation reaction. And you need to understand the Nernst equation. So whenever you have non-standard conditions, you're most likely not going to need extensive calculations. Instead, you need to know how concentration changes are going to qualitatively affect the cell potential. So on the exam, you can expect MCAT questions that are going to involve scenarios such as neurotransmission or bioenergetics. They really love relating electrochemical principles to biological systems. Quick recap. You want to understand oxidation reduction, galvanic versus electrolytic cells, and the Nernst equation concepts to really be able to nail this topic whenever it comes up on the exam. Okay, last one, topic 3, thermodynamics. Why thermodynamics is important for the MCAT? It's because the thermodynamics really are going to underpin all chemical reactions that you see. Metabolism and physics. It's really one of those core MCAT fundamentals. Your must-know concepts are all of your laws of thermodynamics. The first law is the law of energy conservation. The second law is your entropy increasing. And the third law is zero entropy at absolute zero temperatures. So let's, next one, enthalpy, delta H, exothermic versus endothermic reactions. You want to know how to interpret delta H values, especially positive versus negative. Entropy, another really important one, delta S. Entropy is going to essentially measure your disorder, more or less. You want to know what increases entropy, so more particles, higher temperature, more gas, state changes. And then also you need to know Gibbs free energy, delta G. Your delta G is going to determine your spontaneity, whether it's product favored or not. Negative delta G, spontaneous, product favored. Understand clearly your sort of golden equation of thermodynamics, delta G equals delta H minus T delta S. A typical MCAT question you'll see is maybe Gibbs free energy questions tied directly to biological processes, such as maybe ATP hydrolysis, enzyme catalyzed reactions, maybe some of the metabolic pathways. So, quick recap. Mastering thermodynamics basics is going to really set you up to be able to interpret a pretty wide range of MCAT science passages. So these three topics, acid-base chemistry, electrochemistry, and thermodynamics, are going to form essentially the backbone of Gen Chem on the MCAT. Your best strategy that you can use is regular, active, practiced. Don't just memorize your formulas. Formulas don't mean anything if you don't know how to use them. So practice using the formulas in MCAT style scenarios every single week. I hope this was really helpful for you guys. I hope maybe it clarified exactly what topics deserve the most attention in your Gen Chem as you study. If you want more content like this, or if maybe you're looking for a more structured plan to really hit your dream MCAT score, follow me and let me know in the comments what you maybe want to see next. You are capable, you have got this, and I am here cheering you on every step of the way. See you guys next time.